Now, this is your chance to ask questions, so, feel free to do that. So, question number 1. Solve for x. These are all the problems we've done over the past couple of weeks. Okay, the first thing I'm doing is looking to see that I have the right question. Okay, then I'm going to draw a line and I'm going to write the problem over again. Then I'm going to find the number that 2, 4, 3, and 4 go into evenly. That is called the LCM, the least common multiple. The least common multiple of 2, 4, and 3, obviously the 4 we don't have to use twice. This is the way if you have trouble determining, if you don't know it's 12, you don't have to know it's 12. This is the way you would do it. You would say, well, does 2 go into 4? No. Yes. Yes. 3? No. Okay, so take the 4 and double it. And 3 still doesn't go into 8, so that can't be it. And you try 12. And 2 into 12 works, 3 into 12 works, and 4 into 12 works. That's how you find the least common multiple. Once you find the least common multiple, every term gets multiplied by the 12. And you go like this. 2 into 12 is 6. 6 times 1x is 6x. 4 into 12 is 3. 3 times 1 is 3. 3 into 12 is 4. 4 times 2x is 8x. And 4 into 12 is 3. And 3 times 3 is 9. And then if I were you, I would draw a line. Otherwise, stuff starts running into each other. If you're taking a test, you want the test taker, namely me, to have an easy time grading your paper. If the test taker, if the test grader is having a difficult time, that's nerve-wracking, and it's not, it puts them in a bad mood. So you want to make it as easy as possible for me. Really, I'm not just saying this because out of a self-serving kind of thing. It's true. Like if I see sometimes I see like the work is all over the place. Like there's some work here, some work there, some work at the bottom, some work over. Just keep it all in order. That's how you should even do the test. When you actually take the test, have question 1, number 2, number 3. Don't have number 8 followed by number 1, followed by number 10, followed by number 3. Keep it all in order from 1 to 10. Makes it easier for me. Okay, now I'm bringing the x's to one side of the equation. In this case, I'm bringing everything to the left. That drops out. You get negative 2x, negative 3 equals 9. Bring over the 3. Negative 2x equals 12. Divide by negative 2. And x equals negative 6.
Professor?
Now, if I made a mistake, don't tell me.
No, it's not about that.
Okay, so hold off for 1 second. Who has
Okay.
the question?
Fama.
Fama, hold on to the question for 1 minute. I'm checking my work just to make sure I did everything correctly. Okay, what's your question, Fama?
So when I do a solve for x equation, I found -6, but I don't like remove the same number from the left to the right. If it
That's,
makes sense, for
that's,
example, I
that's
just
fine. I
I
know.
just take the
Put
number to the right
-6,
or the left.
that's fine, that's fine.
Okay. Yeah, because you said to do the way you taught us to do, but I've just
No,
been
no,
used to doing this for so long. So
that's different, that's different.
okay,
Like when I
okay,
say do it the way I wanna do it, it doesn't mean you have to do -8, -8. It means
okay,
just do it in this way, but if you wanted to do -6, -6, that's fine.
yes,
Yeah, no,
okay.
no, that's not what I meant.
All right, thank you.
Okay, you're welcome. Good question. Excellent. This is your chance to ask questions. So, this is what we're here for today. Okay, that's question one. That's, worth 10 points. And I try to base it on how much work there is. It's very difficult to identify the number of points, but here's question number 2. 3 times the absolute value of y minus 1 minus 10 is equal to 5. Once again, my first step is to. Now, that's interesting that you asked that question, Fama, because it's just that some students do the problem, not this problem, but other problems, totally differently, totally different method. That's what, I don't want, but as long as you're doing it and you're bringing different numbers back and forth, that's fine, that's. Okay, so what I would do is get rid of everything around the absolute value. So we do this first. And we get 3 times the absolute value of y minus 1, that drops out, equals 15. Divide by 3. The absolute value of y minus 1 equals 5. And I'm checking my work. Okay, now for absolute value, in this absolute value sign can be a positive 5 or a negative 5. So you take both into account. Y minus 1 is equal to positive 5, and y minus 1 is equal to negative 5. And then you solve each of these two equations. These are very simple equations. Y can equal 6. And y can equal -4. And those are the two answers. And if you want to check it, you could do an informal check. You could, just informally just take the 6. 6 minus 1 is 5. Absolute value of 5 is 5. 3 times 5 is 15. 15 minus 10 is 5. Using the -1, -4 rather. -4, -1. Absolute value of -5 is 5. 15, same thing. So that's fine. Problem number 3. Solve for x and express the answer in graphical form and also interval notation. -3 x minus 2 minus 15 greater than or equal to -18. Okay, a lot of negatives there for a reason. So I would solve this equation, inequality. It's not an equation, it's an inequality. Solve the inequality exactly the way we solve an equation, at least at the beginning. You're going to do this. You could multiply -3 times x, -3 times -2, I suppose, but I would divide everything by -3. That's how I would do it. And you get rid of these. You're left with x minus 2. -3 divided by -3 is +1. And because we divided by a negative number, the inequality symbol reverses. When you divide by a negative number on both sides of an inequality, the inequality symbol reverses. And you continue. X is less than or equal to 3. Now, you were told, now first let me look at this. See if I got this right. Based on what I did. Okay, so we reverse it because we're dividing this negative number that we're dividing by causes this to become reversed. Okay. Now, so you're going to express the answer 2 ways. First, in gray, as on a number line. And here's 3. Doesn't have to be perfect. This is infinity. This is negative infinity. So we want shaded in because of that line underneath there. That shading in is caused by the fact that there's a line underneath the inequality sign, shaded in, and then less than, all the way back here like this. This is the graph on the number line. And in interval notation, it will be 3, and it'll be brackets. It'll be brackets, again, because that's shaded in, and that's a line underneath the inequality. And going in this direction to negative infinity, and that will be parentheses. Infinity will always be parentheses, not brackets. And that's the complete problem.
Professor, I have a question.
Yes, Kariatu.
Oh, I don't know where I did wrong. I got -3. Like I start the first line by multiply -3 and x and -3 by -2.
Right.
And then I got -3.
Let me write what you said, 3x. See, you should have 3x plus 6, right?
Yeah, plus 6.
Minus 15,
15.
greater than or equal to -18.
Yes.
And then, did you
And
combine
then,
like terms?
yes. And
All
then
right.
I have
What'd you get?
minus
What'd you get?
-3x minus
Yeah.
9.
-9, good. Okay. Go ahead.
Yes, and then I have plus 9
Okay.
minus 3x minus 9.
And then what?
Oh yeah, I forgot to add the sign.
Okay. You mean this sign?
Yeah, the -9. I
Oh,
just
You
did.
didn't have -9, you had +9.
Yes, yes,
Okay, that's a 1-point mistake.
yeah.
That's 1 point. That's a small mistake. That's not a serious mistake. Okay?
Okay, thank you.
Good question. Good question. All righty. No more questions about number 3. We move on to number 4. Solve for X. Absolute value of X minus 9 less than or equal to 3. Graph the solution and express the solution in interval notation. Where from here, you go to X minus 9 less than or equal to 3. And because it's less than, it's and also, not or, it's either or and. And X minus 9 greater than or equal to negative 3. Now, let me show you the opposite type, not the opposite, but the complementary problem would be this one. I don't remember which one's on the test. I'm not just saying that, you know, to be coy. I'm telling you that because I just don't remember. But the other possibility would be if you have a greater than sign, then you see here it's an and this is the way you set it up. This symbol, the greater than, is an or. And it would be X minus 9 greater than or equal to 3, or X minus 9 less than or equal to negative 3. So I'm not sure which, I don't know, I don't remember which one you're going to get. And I don't think I tell you anyway, either this one or that one. But you got to be ready for both. Now let's do both. So let's start here. So here you just add 9. X is less than or equal to 12. And X is greater than or equal to 6. So on a number line, here's 6, here's 12, here's infinity, here's negative infinity, here's 12, that's shaded in. It's less than or equal to 12, but greater than or equal to 6. And this is what it looks like. And in interval notation, this would be 6 and 12. This is the problem that was on the practice test. But the other possibility, if I wanted to give you the other, there's only 2 possibilities. Either this is less than or equal to, or it's greater than or equal to. If I had given you greater than or equal to, this is how you set it up. And you continue the way we did over there. X is greater than or equal to 12, or X is less than or equal to 6. So what does that look like? Let's, it's always hard to imagine what these things look like unless you put them on a number line. So this is this one. This one would be shaded in greater than. This would be shaded in less than. See, they go in opposite directions. When it's or, they go in opposite directions. When it's and, they go together in the same, they're kind of moving together. It's everything in here. Negative infinity, 6 in bracket, because that's a shaded in circle, because that's a line under there. So that's negative infinity, 6, or 12 and infinity. And that's the two possibilities. You will get one of them on the test. So I would suggest knowing both, just in case. You don't know,
I have a question.
Michelle, yeah.
Yes, so, um, does it matter if we put like the symbol of or if we just put the word or?
Yeah, I would not mark it wrong. You know, if, here you put or instead of the symbol,
Yeah, like if I just write the word or instead of the symbol, will we lose points?
I wouldn't mark that wrong. I wouldn't mark that.
Okay,
I think that, as a pre-calculus student, you should move in the direction of learning to use this symbol instead of the or. But for this particular test, I would not mark it incorrect. You would lose no points for
okay, thank you.
that. Anybody else? Okay. Problem number 5. The endpoints of a diameter of a circle are 4 and 1 and -2 and 9. Okay, so, picture this. Write the equation of the circle with a question mark. But anyway. So this is what you're given. You're given that in the coordinate plane, there are 2 points, 4, 1. This is a sketch, it's not going to be exact, it's just a sketch. And -2, let's say 9 would be up here. -2, 9. So what you're being told is that this is a diameter of a circle and we want, obviously that's not a great circle. It doesn't have to be, just a sketch. Write the equation of the circle. Now, the equation of a circle in general will be x minus h squared plus y minus k squared equals r squared, where hk equals the center of the circle. And r is the length of the radius. So what we want to do with the 2 points that are given is find the center, find the midpoint. The midpoint, because the key aspect here is that the midpoint of the diameter is the center of the circle. This is the key thing here. The midpoint of the diameter, this midpoint, right in the middle there. If we could find that, that will tell us the center of the circle, which will permit us to know what h and k are equal to. And that's half the problem. Half the problem is finding the center of the circle. So the first step, step one, is to find the x coordinate of the midpoint, x1 plus x2 over 2, and that will give us h and y coordinate of the midpoint, y1 plus y2 over 2, which would give us k. So you see how valuable that is to find the midpoint. And let's do that using the 2 points that we're given. So this is x1, y1. This is x2, y2. And x1 plus x2 is 4 plus -2. 4 plus -2 divided by 2. Which is equal to 2 over 2, which equals 1. The x coordinate of the midpoint is 1, which is the same thing as saying h is equal to 1. And now we do the y coordinate. So y sub m will equal 1 plus 9 over 2, which equals 10 over 2, which equals 5. So the y coordinate of the midpoint is 5, which means that k is equal to 5. Let's see if that makes sense. x1, yep, that, that's close. That looks like, that could be. Because, here's 1, and we go up 5, so that makes sense. Okay. Now we go back to the general form of the circle and substitute x minus h squared plus y minus 5 squared equals r squared. So that's what we know so far. Very important. We know what the center of the circle is, and we're able to get at least this much of the formula. So now we want to know how we could find the length of the radius. See, we need to know r, which is the length of the radius, which is, right here. This is, the relationship between the radius and the diameter is that the radius is half the diameter. So we could either find the length of this line, not there, there. We could either find the length of this line and use -2, 9, and 1, 5, or we could find the length of this line and use 1, 5, and 4, 1. So, I don't know. I'm going to find the length of this line, this radius, not that one. You could use this one, you could use this one. I'm choosing that one. So you're going to use the distance formula. The length of the radius can be found by using the distance formula, namely x2 minus x1 squared plus y2 minus y1 squared. And let's see what we get here. But first we have to identify this stuff. So here we have, call this x1, y1, x2, y2. It's it's not the same x1, y1 as up there. right? So once you do that, you have two other points that you're trying to find the length of the line. So it's different x1s and y1s and x2s and y2s. Okay, but it doesn't matter, because basically what you're doing is you're subtracting the x's. So 4 minus 1 and 1 minus 5. Okay, let's see what we get here. 4 minus 1 is 3. 1 minus 4 is 1 minus 5 is -4. My mind was thinking ahead. So I gave, the actual answer instead of the question. Three squared is 9. -4 squared is 16. The square root of 25. That's nice and works out very nice, right? Square root of 25 is 5. See, I wrote my 5, which looks like an S, right? That's my problem, one of my problems. A teacher of mine used to call it the lazy 5. The radius is equal to 5. Take this back and substitute it in the formula. X minus 1 squared plus y minus 5 squared equals 5 squared. And you could change that 5 squared to 25. I'll accept either answer. I'll accept either one. And that's a 12-point question. Because, as you can see, there's a lot going on there.
Professor, what if we leave the square root of 25 in the equation just like that instead of 25? Is that wrong too? On the final equation where you got
I mean, it wouldn't be the square, I mean, it wouldn't be x minus 1 squared plus y minus 5 squared equals the square root of 25. That's not what it's gonna be anyway. It's gonna be this.
all right. So then we switch it and leave it as 25 or 5 square. All right,
Yes,
I got it. All right, thank you, Professor.
you're welcome. Very good question.
I have a question.
Well, 1 second, let's focus on the original question. So this, yeah, you got this, and then, but so this is the length of the radius, but then you have to square it. And you really shouldn't leave it like this. If you're gonna do this, you might as well do that. Yes, somebody else has a question. Go ahead.
Can you re-explain the bottom left side again, where it says x2 minus x1 in the square root?
Here,
Yeah,
Well,
can you explain from there
this,
bottom?
this is the distance formula. This is called the distance formula. And we need to use that to find the length of the radius. Okay, that's the way you find the length of a line given the 2 points. Given 2 points, this is the formula to use to find the length of the line segment that connects those 2 points. So I'm using the 2 points. I should have put that here. 1, 5 and 4, 1. Those are the 2 points I'm using. So it's x2 minus x. Now I'm using these 2 points. So from the center of the circle to the actual circle, That's a radius. That's called the radius. The line that's drawn from the center of the circle to the actual circle, that's called the radius. So you could have done these 2 points because this is also a radius. But I decided to use this one. I liked it better because it had no negatives. So I used that one. And that's what I used down here. And, you know, x2 is you know, it's the second value of x minus the first value of x. That's what this formula means. 4 minus 1. And then 1 minus 5. And then I, you know, worked it out. Got 3 there, -4 there, squared it. That's it. Now, I'll tell you one thing. Some people I've seen do 4 minus 1 and 5 minus 1. They would have gotten away with it in this situation. But sometimes you don't get away with it. So, you know,
Okay.
if you do 4 minus, if you go in this direction, 4 minus 1, you also have to go in this direction, 1 minus 5. I hope that answers your question.
It did. Thank you so much.
You're welcome.
I have
Thank you
another
for asking
question.
the question, Michelle.
I think you said it before, but just to be sure, is it okay like if we do 1 minus 4 or 5 minus 1?
If you do one, you know, if you do 4 minus 1, you also want to do 5 minus 1, right? That's okay. In other words, it's not only x2 minus x1, it could be x1 minus x2. But if you do x1 minus x2, it has to be y1 minus y2. So then, you know, if you did 4 minus 1 minus 4, then this would be 5 minus 1. Did you get 25?
Well, I did it the way you did it, but like just in case if I like,
Yeah,
I
yeah,
know that
yes,
yeah, if I switch to x1, yeah, just
yes.
to make sure.
Didn't we
Okay.
cover this last time?
Yeah, I know you said it last
Yeah,
time.
well,
I just wanted to.
that's okay, that's okay, that's okay. I know it's a critical point, so it's like, you know, that's fine. That's fine. 6. What is the equation of the line which passes through the point -1, 5, and another point 1, -1? The equation of the line. Okay, well, do I say in, you know, I don't say it on the practice test, but I do say it on the real test, I believe. I say in slope intercept form. Oh, there's a test right over there. Didn't realize it. Slope intercept. So not only find the equation of the line, but there are different forms of an equation you could draw, you could write. We're using something called slope intercept. Slope intercept, which is y equals mx plus b. This is important. This is the slope intercept form of a straight line. And that's the equation, the general equation that we're going to use to do this problem. So the first thing we need to find, so in this formula, the m represents the slope and the y represents the y-intercept. The y-intercept. Okay, so let's find the slope first. So slope. The formula that you use for slope is y2 minus y1 over x2 minus x1. And if you want to, you could indicate x1, y1, x2, y2, if you'd like. That makes it easier. And this would equal -1 minus 5 over 1 minus -1. You could do the same thing here. You could do 5 minus, you could do 5 minus -1 and then -1 minus 1. So, you could do that as well, but this is the formula. This is delta y over delta x. Remember that? Delta y over delta x. The change in y over the change in x. And let's now evaluate this. Let's rewrite it. So -1 minus 5 is -6. And when you subtract sign numbers, you change the sign, you get 2. And the slope is equal to -3. You take this and put it in the original equation, the original slope-intercept form. Y equals, instead of m, it's -3x plus b. So you do this first. You find the slope. Step 1. Find the slope. All righty. And then to find what b is equal to, you take one of these 2 points. It doesn't matter which one you use. You could use this one and then check by using that one. But let's pick one of the points. I don't really, care what we use. Let's use this one. This is the one. This is the first one. Let's use this one. So this is 5 equals -3 times -1 plus b. All right, so the x goes there, the y goes there. 5 equals 3 plus b. -3, -3. B equals 2. Or, 2 equals B, or B equals 2. So let's put that back into here. So y equals -3x plus 2. This is the answer. This is the equation of the line. This is the equation of the line in slope-intercept form of the line segment, or the line that has these 2 points on it.
Professor, wait, how did you get the 5 again? For where the y equals, how did you get 5 equals?
Where did this 5 come from?
Yes.
From here.
Oh, okay.
I used this point. So y is equal to 5 and x was equal to -1. So that's what I used.
So it gotta be x1 and y1.
Yes. You could have used x2 and y2. It didn't matter. Doesn't matter.
Oh, okay.
I have a question.
Yes, Jaden.
So for the very beginning where it says 1 minus parentheses -1, right under it you put you changed it from 1 plus to parentheses +1. Why did you change it?
Because when you subtract sign numbers, the rule is to change the sign of the second number. and change the operation to addition. So I changed the sign from negative to positive, and then changed the subtraction sign to an addition sign. That's the rule for subtraction of sign numbers.
Okay, thank you so much.
Professor, the place where you wrote y equals to minus 3x plus b, after minus 3, you put the x value as minus 1. Is it okay? I mean, if I put any value of x, or do I have to put the first value, which is x1 or x2? Which
No,
one should I put?
You could have used this, you mean use this one instead of using this one?
Oh, so it means I can use any value of x, right?
Well, no, you can't use any value of x. You only have two
I
choices.
mean the value which is given, like x1 or x2, any of them.
You could use either this one or this one,
Oh, okay. Thank you so much.
because these are the 2 points. I could have avoided this altogether and just used that one. You know, I would have said y equals negative 3x plus b, and then said in place of y, I'm gonna use the negative 1, and in place of the x, I'm gonna use the 1. And then worked it out. Same answer. B equals 2, B equals 2. Didn't matter. Could have used the first point, could have used the second point. I picked the first one. I don't know why. Because it was first.
Thank you, Professor.
You're welcome. So let's do number 7. Find the difference quotient. So this is what you're given. You're given that f of x is equal to 5x minus x squared. And then you're told to evaluate the difference quotient. This is what the difference quotient is. And of course, h cannot equal 0. Because then the fraction's undefined. This is an important question because for any number of reasons, not least of which is that it's on the final. But also because it's, as I told you, it's the very beginning of calculus. I think it's, I haven't taught calculus in a while, so I can't tell you where it is in the curriculum, but it's at the very beginning of the semester. So we want to evaluate this using this function. So what we do is, in place of the x in parentheses, we put -2 plus h. F of -2 plus h. That's what this means. This means that this is the function we're using. And we want to find f of -2 plus h, so we go over here, substitute the -2 plus h in place of the x. Wherever you see an x in this expression, it's 5 times -2 plus h minus -2 plus h squared. I'm challenged when it comes to writing the number 5, obviously. Okay. Well, the first part of this is not difficult. That we'll take aside and do separately. But this, let's do this first. 5 times -2 is -10. 5 times h is 5h. Now, this whole thing we're going to do over here. All right, so -2 plus h squared, which means negative 2h plus h times itself. Okay, so I'm going to do this separately. And the way you multiply binomials is to multiply this way, negative 2 times negative 2, positive 4, negative 2h, negative 2h, plus h squared. Now, I'm sitting back to let people look at it. And hopefully nobody will have a question. So I multiply this way, this way, this way, and this way.
And cross.
And you wind up with 4 minus 4h plus h squared. If you wanted to, you could have multiplied these two, not top over bottom. You could have done it this way. You could have done negative 2 times negative 2 is positive 4. Negative 2 times positive h is negative 2h. Negative 2h. Why do I keep putting a b there instead of an h? Plus h squared. And you see that you get the same answer from here, here, and this could be a check. But this whole thing goes back in here. 4 minus 4h plus h squared with no exponent because we've already done the multiplication. But this is where we are now. Tough little problem. Everything's here. It's a lot going on here. Now, I would like to now get rid of these parentheses. So this is like a 1. So negative 1 times 4 is negative 4. Negative 1 times negative 4h is positive 4h. Negative 1 times h squared is negative h squared. And now we combine like terms. Well,
Professor, I have a question. I want to know from where did the -1 came before the bracket?
I just put it there. After I had multiplied this out, I wound up with this. I invented the 1. This is what I had. But I did a problem like this once, and I used the negative, and somebody said, "Hey, can't you put a 1 there?" So I figured for that person I would put a 1.
Oh, okay, thank you.
So I put the 1. If it helps you to have a number there, then put a number there. There's no problem with that. So, okay, we're down here. We're combining like terms. So negative 10 and negative 4 is negative 14. And then we're finished with those two. And then 5h and 4h is 9h minus h squared. So what we just found out is that f of negative 2 plus h is equal to, let's turn it around. Putting the negative h squared plus the 9h minus 14. This is very, 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 very important.
Professor, I'm so confused. I thought like -2 plus h parentheses like squared would be 4 plus 4h.
Why would, you mean you thought that this,
Because
you're adding two negatives?
yeah, that would be 4, right?
Negative,
Where
negative,
did
negative,
so
negative. If you're adding a -2 plus a -2, that means like on the number line, you're starting at -2 and you're adding -2 more, that's -3, -4. This is equal to -4.
oh, I did -2 times -2, but still I wouldn't know where the other 4 came from, but
What do you mean? -2 times -2 is +4.
yeah, I got that.
-2 times h. So I went this way, then I went this way. -2 times h, -2h. Then I went this way. -2 times h, -2h again. And then h times h is h squared. So there's 2h, -2h, -2h is -4h, and then the original 4 from 2 times 2 is 4.
It's not you. I'm just remembering a lot of stuff. I'm trying to
No,
remember.
it's not me, but I'm trying to be helpful.
Yeah, I know. It's just I'm trying to remember every single
I know, don't,
everything.
that's why I have a job. That's why I've been doing this for 55 years, because people have trouble with math. It's a known fact, people have trouble with math. Really, I mean, everybody I know, every time I speak to somebody and they say, what do what do you teach? I say, well, I'm a professor of mathematics. Oh my God, I always did lousy in math. Everybody says that. Because it's hard. Not because they're dumb or anything. You're an intelligent person. It's hard to remember all these little things. I don't discount that as a factor in teaching a course. That's part of it. That's, part of the whole thing. So if you're struggling, I'm sorry, and I understand it, but you have to focus on it and try to plow through it. And I'm quite willing to do basic arithmetic, this basic arithmetic, really, or basic algebra, and I'm quite willing to go back and forth and back and forth,
Maybe try to do it again, Professor. Maybe that will help for her too.
Well, I did it again. It's on my
No,
video.
it's okay. I just
I want to finish this thing and I wanted to do more questions, so I don't know, but you want me to do it over again? I'll do it over again.
no, it's okay. I'm gonna write it down and then I'm good at breaking down stuff once it's down on paper.
Well, just look, do this. Look at this right here. This from here to here. This is just, focus on that and go back at the video and, and I did it again here, but I did it over here. I did it vertically. Here, I did it horizontally. But you get the same answer. So anyway, so what'd you get? 4h squared? Or
I
something?
think the horizontal will be easier for her to understand.
Well, that's for
Well,
her.
for me, it's easier horizontal.
All right, well, that's helpful, Jennifer, but Karana, I mean, it's right. It's you talking, right?
Yeah. Yeah.
Well, how you doing now? Any, no, still nothing?
Professor, was Stephanie that was having the problem. I'm good. We can move
Yeah.
forward.
Oh, I'm sorry, not Karana. My
Okay.
apologies, Jennifer.
You know, I was about to say
Hold
something,
on.
but I didn't want to interrupt.
Now I'm confused. Who was it? I want to know who.
It was Stephanie.
Stephanie, I'm sorry, Stephanie. I'm sorry. Yeah, it was Stephanie. It's all right. Don't feel bad. Don't feel bad. This is, you know, it's tough stuff. But I'm not saying it is. Okay, so we have this. Now, okay, so we evaluated this part of it. Now we need to evaluate this part of it. So we do this now. F of -2. So f of -2, so we use 5x minus x squared. 5x minus x squared, and it's gonna be 5 times -2 minus -2 squared. So when you see something like this, it means in place of the x. See, this is what it starts out looking like. See, this is the original, right? F of x equals that, but we don't want f of x. We want f of -2. So this is f of -2, and that equals -10 minus 4. -2 times -2 is +4. And this is -14. So f of -2 turned out to equal -14. And I once told you, I believe, that this has to equal this. See, this is no coincidence. This is no coincidence, folks. Okay, now we're gonna take this and substitute it in here. So instead of f of -2 plus h, we're going to have -h, draw a line, -h squared plus.
Professor, could you angle the camera up a little bit?
Yeah, thank you for telling me. H squared. Thank you for, that's very important that you tell me that. Plus 9h minus 14. Okay, that's this part. This part goes to this, and then this part minus -14 over h. Okay. And well, you know, this becomes the sign changes. Jaden, the sign changes again. See the same thing happen here? See, we had the same situation as before. Remember when you had that question? With the
Yeah, I
negative
see
sign?
it now.
So, you know, that became positive. So this cancels out with that, and you're left with -h squared plus 9h divided by h. We're getting there. One more step. So this is -h squared over h plus 9h over h. You should have put this later in the workbook, after you've had a little more sophistication of this problem. Jeez. Maybe 12 points is not enough for this one. All right, so, I mean, this is easy, right? You just cross the h's out. And h squared over h is the same thing as h times h over h, because h squared is equal to h times h. That cancels out. You get -h plus 9. This is the answer.
I have a question. Yeah. Hello. You see where you did the f of, you see, minus 2 plus h equals negative h squared plus 9h minus 14, the one that you have circled, a little lower, right there, that one. So, did it matter? Because I know you flipped it. Like, instead of negative 14
Did it matter?
plus
No,
9h.
no,
No, it
you
doesn't
could have
matter.
left,
Okay.
you could have left it this way. Nobody would have said anything if you had left it. It's fine,
Okay.
it's fine. No, it's fine.
Okay. Thank you.
As long as you wound up with, you know, after all this, you wound up with this fraction. This was our goal to get to that point. Because once we get there, I don't want to use the word simple, but it flows very nicely from here to here. Let's put it that way. I don't want to say it's easy. Nothing is easy.
I have a question.
Yes,
Where did you get -2 from? It's f of parentheses -2
yeah, from here.
equals.
Yeah.
I can't see where you're pointing.
Oh, so I'm sorry. So, yeah.
Oh, okay, that makes a lot more
So
sense.
f of x. See, this is the key thing right here, right here. But instead of x, I substituted -2. Actually, instead of the x, I substituted first -2 plus h. That was this part. So you do this part first, then you do f of -2, and that's what I did over here. That was a lot easier.
Yeah, I understand it now. As soon as you showed me that, I instantly got it.
Okay, good. And we're moving on to question number 8. Oh, a nice. Oh, I'm not gonna say it. Solve for x and y. And here it is. 3x minus 5y equals 13. -2x -3y equals 4. Now, there are obviously a few ways of doing this. I would say that the easiest is to multiply the top equation by 2 and the bottom equation by 3. The idea is to get rid of one of the variables. So since there was a +3 here and a -2 there, then if we multiply this by 2, that'll give us 6x. This will give us -6x, and they'll cancel out. Here, since they have the same sign, you'd have to also multiply by, a negative. You'd have to like do 3 up here and then -5 down here. So this is the way I've chosen. And you get 6x minus 10y equals 26. The second equation is -6x. -9y equals 12. The 6's drop out. This becomes -19y equals 38. Divide by -19. And y is equal to -2. All right, so I solved for y, but somebody else, did anybody solve for x? Did anybody get rid of the y's instead of getting rid of the x?
Yes.
Yes, all right, let's see if it should come out to the same answer, obviously. So now what we would do is take one of the two equations, and I'm taking the top one and substituting -2 for y. So this -2 gets substituted in here, and that will give us 3x plus 10 equals 13. 3x equals 3. And x is equal to 1. And the answer is 1, -2. Checking. And I'm substituting the 2 points, -2 times 1 minus 3 times -2 equals 4, hopefully. And this is -2 plus 6 is equal to 4. So there's your check. That's the check.
Yeah, I was just a little confused at the beginning. How did you get the 2 and the 3 before the problem?
Well, I realized that in order to solve these two equations together, you had to get rid of either the x's or the y's. So I realized that if I put the 2 up here and the 3 over there, I'll wind up with the same number, 6. See the 6? This is my goal, to get this number the same as that number, and to make sure that one of them had a negative and one of them had a positive. So that's where I got that from. I just said, I basically said, what's the least common multiple between 3 and 2? And it was 6. So to get from the 3 to the 6, I multiplied by the 2. To get from the 2 to the 6, I multiplied by 3. Now, somebody else did the same problem by multiplying this equation by 3 and this equation by 5. And that would be a 15 in the middle. But you'd have to make sure that one of them had a different sign. So you'd have to either multiply the top one by negative or the bottom one by negative. And that's, that seemed a little more complicated to me, so I chose the first one. Let's go on to number 9. So number 9 is you're given g of x. Can you see that? G of x equals the absolute value of x minus 3 plus 2. And you're told to name and graph the parent function. So that's part A, the parent function. Name and graph the parent function, which means the parent is f of x equals the absolute value of x. We did this on Monday. And to graph it would look like this. That's the parent. Now we want to do this one. So the second part is sketch the graph of g of x. So we take g of x, I'm writing it over again. And I'm remembering that the general formula was f of x equals x minus h plus k, where h and k were the vertex, the coordinates of the vertex. So I draw a sketch. All I want is a sketch. And the vertex is 3, 2. This is the H. This is the K. There it says it right here. Says it right here. So I graph a 3 and a 2. And there's no negative. There's no negative here. So it's just what it is. You just go like this. So it's the parent, but moved over and moved up. This tells us if the parent was moved to the right. This tells us the parent was moved up. And this is what it looks like. And that's the whole problem. I just want to say one thing. If the problem had been, if this had been negative x minus 3, not f, g of x had been negative x minus 3 plus 2, then it would have been, everything would have been the same. See, this still would have been 3, 2. But the negative would have meant that you take this graph and flip it over. So it would have gone like this. That's what the negative sign means to a problem like this. If it's positive, it goes up. If it's negative in front, then it goes down. Just keep that in mind.
Professor, I have a question.
No,
So, the sign inside the absolute value doesn't matter. For example, like when we have x plus 3, we just take the 3.
I don't know what you mean. You just take the 3. If g of x was x plus 3,
Plus 2.
then it would have been negative 3 too. It's always the opposite sign.
Oh, okay, that was my question.
If it's positive 3,
Mm.
it's negative 3. If it's negative 3, it's positive 3. Good question.
Okay, thank
Good,
you.
good clarifying question. Excellent. Right? That's a very, very important point, because I was waiting for somebody to say, if you had a negative 3, why isn't this a negative 3? Well, if this is negative, that's positive. If this is positive, then that's negative. It's always the opposite sign. It's weird, but it's not really weird. I'm just saying it's weird. You know, to kind of go along with everybody, but it's not really weird if you think about it. Anybody else with this?
Yeah, so basically the parent function, every time it asks for that, it's the f of x, which equals the absolute value of x.
Yeah, if this is the parent, no matter what. When I say on the test, graph the parent function, this is it. I mean, this could change. This will change. I'm not going to keep 3 and 2. I'm going to change it, but the parent always looks the same. The thing is that this is the parent function, and it moves around based on what this number is and what that number is and what the sign is over here. See, the real formula here is A. Well, screw that. See, this is really what it is. This is really what the formula, the general formula is. with the A in front. And the A tells us whether it's positive or negative. If it's negative, it goes down. Here's problem number 10. The last question. So part A says, find f of -5 if f of x equals -3x squared plus 7x minus 2. And all that's saying is, instead of the x, substitute the -5. We actually did this earlier in the class. It's just, it's just that this is a more elaborate expression. -3 just means wherever you see an x, you substitute a -5. I just, wherever I saw an x, I put a -5. Then the order of operations tells us that we do exponents first. So -5 times -5 is positive 25. Bring everything else down. So this is -75, -35, -2. And since they're all negative, we just have to add up all of these three. So let's see, did I do this right? -3, yep. Okay, well, I don't know, -5, 75, -35, and -2. Add them all up. -112. Problem B. Problem B, question 1. So the question is, state in interval notation the domain. We want to know the domain. This was the last thing we did on Monday. Well, not the last thing, but one of the things. F of x equals 8x minus 5. The domain for any linear equation, well, there are a couple of exceptions, but as far as you're concerned, this answer will always have the same answer. It's all real numbers. I said this on Monday, all real numbers. You can either write it like that, you could use this symbol. All real numbers. The problem is when you have f of x equals a square root, because you cannot have a negative, you cannot have a negative number under the square root. The problem is this cannot exist with a negative number underneath. So therefore, x minus 7 must be greater than or equal to 0. This is the domain, and you just have to solve it. +7, +7. X is greater than or equal to 7, which means that the domain will be 7 to infinity. Again, you can't have a negative underneath a radical sign. Well, a square root, not all radicals, because you can't have a negative if it's a third root. We'll do that. When do we do that? A couple of chapters from now. All right, so that's that type of problem. And the other problem where there's a difficulty occurs when f of x equals 2x over x plus 3. this fraction is not defined when the denominator is 0. You can't have a fraction with a 0 denominator. So therefore, you set the denominator equal to 0. Actually, you don't say it's equal to 0, you say the domain will be when x plus 3 does not equal 0. That's the domain. X plus 3 cannot equal 0. Therefore, we solve this, and x cannot equal -3. In other words, on a number line, it's open there because you can't have a -3 because -3 and +3 is 0. So you can't, that can't happen. So it's gonna be everything except that, going in both directions. It's gonna be -infinity to -3 and -3 to infinity. And that's that question.
Please move the board down.
Yes, I'm sorry. Yes, this will be an extra problem. So, okay. So find the difference quotient, and f of x equals x squared minus 3x plus 4. And here it is. F of, let me try to make this look as similar to the question as possible. I'm beginning. So let's let me get my stuff ready here. Okay. So the first step is to rewrite the function and then take the first part of this and substitute wherever you see an x, -5 plus h. So here, instead of x squared, it's -5 plus h squared. Instead of x, it's -5 plus h. And here it's just the 4 because there is no x there. So the first thing we need to do is we need to take -5 plus h and multiply it by -5 plus h. Okay, so this goes here. This is still part of step 1, so I'm not, delineating it really. It's just part of this whole concept of evaluating f of x when x is equal to -5 plus h. Now I'm going to multiply. -5 times -5 is positive 25. -5 times h is -5h. Then h times -5, -5h. I'm lining it up because they're like terms. I'm making it a little easier because they are like terms. And then h times h is h squared. And this is what you wind up with. So this becomes this. So I'm putting it back here. I'm putting it back as 25 minus 10h plus h squared. And now I'm continuing. -3 times -5 is positive 15. negative 3 times h, negative 3h. And then just 4. Now, you need to simplify this. This is like very, very complicated. And it's just a question of combining like terms. So I'm taking the h squared and I'm putting it in front. Then I'm taking the negative 10h, the negative 3h. I get negative 13h. And then I'm adding 25, 15, and 4. And that will give me, looks like what, 44. So the conclusion is f of negative 5 plus h equals h squared minus 13h plus 44. This is the end of the first step. So again, let me restate what I just did. This is what I'm given right up here. So you take this part and you substitute wherever you see an x, you substitute negative 5 plus h, which is what I did here. And I showed you how I got negative 5 plus h quantity squared to be that. And then that, okay, was over here. And then I brought the 4 of them. Then I combined like terms, and this is what I got. And that's it. That's one of the things. But we have to now find what the other one is. What is f of negative 5? So step 2 is to take f of x equals x squared minus 3x plus 4 and substitute f of negative 5. So negative 5 squared minus 3 times negative 5 plus 4. Negative 5 squared, positive 25. Negative 3 times negative 5, positive 15, and positive 4. And f of negative 5 equals, f of negative 5 equals 44. Remember I said that this is no coincidence? This is the way it's supposed to be. Now, all you have to do is go back. So step 3, after you found what this is, the f of negative 5 plus h and f of negative 5, which we did in step 1 and step 2, now you put it all together and you get h squared minus 13h plus 44 minus f of negative 5, which is 44 over h. And, this is supposed to happen. And you wind up with h squared minus 13h divided by h. H squared over h minus 13h over h. And this becomes h. This becomes 13, and that's the answer.
How did the last 44 become negative?
Because of that. See that?
It's on step, in step 2.
See this negative?
Okay.
That's how it became negative.
Okay.
I have a question.
Professor,
Oh, two people
whoever
asked,
said that can go.
asked the question at the same time. Who goes first? I don't know. Who wants to go first?
I'll just go first.
Yeah,
Um,
you could go.
Coretta, go ahead.
I came to the same conclusion, but I kind of combined certain steps. So if again, I got the same
That's
answer.
fine. I
That's
know what you're
fine.
gonna say. I know what you're gonna say because I said at the very beginning, you have to do it the way I do it. But that doesn't mean every single thing has to be the same. If you could shortcut it, that's fine.
Yeah, all right.
Yeah,
Okay.
sure, absolutely.
So like specifically, like if I didn't put h squared minus 13h plus 44, I'm not getting points taken off because I got h squared minus 13h, but I think you can understand why I got that.
Whoa.
Because I combined step 2 with step 1 before combining like terms, and then I canceled out the same numbers with different signs.
Well, I'd like to see this. You didn't have this part?
No, I do have that part, just not the 44 on it.
Oh.
Like I said, I combined like terms, but included
Where
part
did you get rid of the 44s though?
I didn't combine 25, 15, and 4. I left them as is, distributed the negative. This way I can cancel out all the numbers at once from part A and part B.
Oh, I see. Yeah, that's fine. That's fine.
Okay.
That's fine. Creative. Very, very interesting. Very nice. Yeah, because I had to add 25, 15, and 4, and then I had to do it again because I forgot what it was the first time. You don't have to do that. You just cancel it all out.
Are
That's
you
good.
able to show us what she did? Like, because I don't understand what she did. Maybe it'll be easier for most
No,
of us.
I don't think so. I like it, what she did, but I really don't think it's easier. I think it gave you a long kind of, it was long, right?
It was long to look at, but me personally with my brain, being able to see it and physically like cross the numbers out, that took so much time off the process.
Also, you had to make sure that you distribute the negative sign here among all those terms, right? Those 3 terms. You know,
Yeah.
the 25, the 15, and the 4.
I guess to each their own, but for me, it was just a matter of like what worked for my
Okay,
brain.
all right. I think what you did was fine and excellent, but I don't think it's easier. I really don't. I don't think so. I don't, it'll be in the video, and if, I mean, I don't want, we're running out of time. I don't want to really go through what you did, but this is what she did. She got this and sort of left it like that, right? You didn't bother combining like terms?
Professor.
I don't know. Jennifer, what's going on?
I couldn't see what you're pointing at because it's upper.
Yeah. Oh, Jesus Christ. It's like that's the drawback of learning online. It doesn't matter. I don't want to go through it. I think it's more complicated, but she saw it. Wow, it's nice. But I think it's more complicated myself, personally. But again, if you got it, I think that's marvelous. Anybody else?
Yeah, I have a question.
Michelle.
So is it okay if instead of doing step 1 first, can I do step 2 first? Because
Okay, yeah.
yeah, because basically when I did step 1, and I guess somewhere I did something wrong because I got a whole other answer instead of 44. When I did step 2, I feel like step 2 is easier. So then I just matched that to fix my step 1 problem.
Okay. I like it. Very, very, very nice. Very, very creative and very, very interesting is all I could say. I'm so pleased that you both did the problem in a very creative way. You know, I mean, if I've been doing a problem for the past, like, I don't know how many years, but, and I'm doing it the same way every time. And then somebody else comes up and says, I did it this way. And I go, oh, you know, very interesting. And then you do it a different way. It's great. That's great. I admire you both for that, but I personally like my way. But I'm very, very, very proud of you both, really. That was very, very interesting what you do. Especially doing step 2 and then doing step 1. That's like, wow. Okay.
Yeah, I just feel like it was for me, step 2 is easier. So
Oh,
I
yeah,
know
for
what I'm
sure.
gonna get that, you know, and then I could just make sure my number matches what I got in
Make
step
sure
2.
the 44 matches. Yeah, yeah, yeah. Good,
Yeah,
good,
yeah.
good.
And then I had to
Yeah,
redo
yeah.
step 1. Yeah.
I mean, it's obvious. Step 2 is so much easier than step 1. I like doing step 1 and getting it over with, and then just saying to myself, all right, now I'm gonna, you know, relax and do step 2. But that's the way I think. That's my brain functioning. Okay, good, nice. You have no idea how pleased I am. Well, you probably do. You probably know how pleased I am because I'm acting pleased. I just love you know, I think it's just wonderful how the students are so creative and they're thinking. It's just, it's wonderful, you know. Okay, are there any other questions? Let's focus on that.